right? Y is negative a times b is equal to negative a times b. Well, seems pretty obvious to me. Obvious to like just by looking at it. Like, why are we even asking this question, right? But we learn some of the properties of numbers, and we can deduce this fact. So starting from negative a times b, let's see. Negative a times b plus a times b is, by the distributive property, negative a plus a times b, right? Negative a is inverse of a, so when they are added together, it's 0. So 0 times b is in fact 0. So what does that mean? Basically, well, we don't even need to think about what it means, right? Since negative a times b plus a times b is equal to 0, what is the inverse of ab? It's minus ab. So if we add both equations by the inverse of ab, we can use the associate property to add these two terms together. Which makes it 0, because this term is the inverse of this term, right? So once they're 0, it gives this term as is. So minus a times b is equal to negative a times b. That's why it is the coolest thing to deduce when we have properties of numbers. Next, it follows immediately that negative times negative a times b is equal to negative a times b. Right. Now note that so we're going to continue to prove it. We obtain so another interesting fact, which is we're going to go briefly over, is that let's use this color. Negative a times negative b is equal to ab. Oh yeah, this is one of those facts we used to remember in primary school, elementary school, or high school. Is that negative times negative is positive, double negative is positive, right? Even in the, when we speak English, double negative means positive. I did not uncover that, which means that I did not cover that. I did not. It's something like that, right? English sentences use double negative to express, even though it may or may not be a good expression semantically, but there's a double negative, means that it's actually positive. Not in emotional sense or anything, but statement of facts, right? Okay, so how do we prove it? Is negative a times negative a plus minus AB is equal to negative A times negative B plus negative A times B, right? Because of the statements we just proved here, right? This negative AB is in fact negative A times B, right? So we're using these statements we proved to deduce another statement one after the other, which is a cool thing in proof. So now we can use the distributive property that they have in common, which is a negative A term. So negative A plus negative A oh no, what am I doing? I did it backwards. So these guys have negative A in common. We're gonna put them out of the bracket, and this is gonna be negative A times minus B plus B, which makes this second term 0. And since it's times 0, it's 0. So now then, we know that these two terms are equal to 0, which means that minus A times negative B is equal to AB. Same process can be done to deduce the if something plus something is equal to 0, the something is equal to the additive inverse of it, like we did in here, but we skipped that part because we've done already. Okay, so that's the part we have proved, and let's see if we can move on further. But before we do that, I'm going to have a PDF version of it ready. So stick around. Let's review your textbooks together, and I want to show you what I'm actually verifying, as opposed to me just reading the textbook and demonstrating it here. Okay, so see you next time. Thank you, everyone. Okay, where was I?